Should I go ahead and start us off?
Yep, it started, so go ahead.
Okay, question 2. Given a 90% confidence interval of 45 and 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? I have, we are 90% confident that the true mean heart rate is between 45 and 145, so that should be B.
B as in boy, yep.
B?
Yes.
Yeah.
A vote. Okay.
And you have different orders too as a test.
Yeah, I know. I was looking at mine and
That's what I wrote them down. Okay, so for number 3, research at the University of Mississippi wanted to determine whether the reaction time in seconds to go no-go stimulus of males differ from that of females. The researcher randomly selected 20 females and 15 males to participate. The no-go stimulus required the student to respond in a particular stimulus and not to respond to other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots for both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? And I say no because the sample size is not large enough.
But
go ahead.
Plot says it's normal, right?
Yeah.
Uh-huh.
So
So then you have to go back to, because what kind of test would this be? What kind of hypothesis test would this be?
But it doesn't matter if the sample size is large or small, if it's normal.
If you do, as long as you do, I don't know, but I think as long as you do the QQ plot and it's normal, then you can say, yes, it's normal because QQ plots are normal.
Yeah, I thought number 6 was right.
That is making more sense.
So I think it's
You,
C.
yes, the distribution of mean or distribution of similar
But what do you think, Verity?
have been determined to be
I think
normal.
it's C.
I think it's
Say
C.
that again. I understand you. Verity?
I think it's C. The distribution of the mean
Is in
of
cat?
each sample is normal since the data have been determined to be normal.
Okay, so C is in cat. Monica, you think C is in cat?
Yeah, I agree with C.
Yeah. And that's number 3. Okay, just making note of that. Number 4. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? Confidence interval for the mean of differences using dependent samples. Confidence interval for blank when standard deviation is unknown. Confidence intervals and differences of mean using independent samples. And confidence interval for sigma when the standard deviation is known. So in this case, we don't know the standard deviation at all, so we can cross off number 4.
Yeah.
And I chose C, the confidence interval for differences of means using independent samples. Because are they independent or are they dependent? Because they have a different number of male and female, but it's also no-go response. So I would think you have to have the go versus no-go.
Yeah.
True.
So I would say it's dependent. So we say the confidence interval for the mean differences as dependent samples.
I think it's independent.
Yeah.
Yeah, I think because the males are not related with the females. Like, they don't say anything like.
Okay.
Yeah, they don't say that it's.
What did you call the mu? What did you called it sigma?
That's mu. Is that mu? And then there's sigma. Which one's mu and which one's sigma? I don't even know anymore.
Looks like an M. Mu looks like an M and a U put together. Mu.
So that you're supposed to be the Okay, so the confidence interval for the population mean. When the population standard deviation is unknown.
Standard deviation, is that the same thing as sigma then?
I don't know. That is a good question.
But I think it might be. Okay, moving on.
So letter C?
You guys want to go with C, right?
Yeah.
Yeah.
Okay.
You want me to read one?
Sure.
I'll go and do one more, and then we can
okay.
speed it up. Because there are like 30 questions. So, a researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 90% 5% confidence interval for the mean savings account of bank customers is found to be between blah, 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 blah. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? It should be compute the 99% confidence interval. No.
Agreed.
Yes, because we're 95%
I wasn't sure
confident.
if it
So it
was
should be.
the 99% confidence interval or obtain the balance of 90 bank customers rather than 30.
Yeah, I agree. I think it's the last one because if you have a larger confidence interval, then you'll have a wider margin of error, not smaller.
Except that our minimum of 30 was already met.
Yeah,
So-
but if you do more than that, then the margin of error gets smaller.
Yeah.
The larger sample size is.
Yeah.
No, I'm seeing that.
All right, let's put D, and then make a note of that if we end up changing it. So let me flag that one.
I've got it. All right.
Yeah. So D. Okay.
Okay.
All right, Charity, go ahead and take over.
Factory make drive shaft. Quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2. Calculate a 95% confidence interval for the true mean length of the shafts and put your answers for the margin of error, lower bound, and upper bound.
Wait.
Okay, so they just broke up question. What was
Yeah,
our
they-
question 5 is now 3 questions. Okay.
Oh,
So the margin of error should be 1.96, right? Based on the 95% confidence interval.
1 point.
Yeah.
I have a question about that. I wrote down 1.96 and did the calculation, but I I had to look at my old papers to figure out what it was, and I forgot how to find it on the applet. Like, what do you do to get that? You forget.
To get the one.
Because I don't remember how to get it on the applet. I just wrote it all down because they gave them to us.
You put the 90. Oh yeah. Go ahead. You put 0.95 in the applet in the upper space.
At the top,
Okay.
Yeah.
and you highlight the middle part.
Oh, just the middle part?
Just the middle.
Yes. So have the middle part. 0.95 and it's 0.96.
Okay.
Oh, 1.96. Got it.
Easier for all of them then if you want the 99th percentile and stuff.
You just put 0.99 at the top.
I'm so glad you told me that. I could not remember
Yes,
how to
that was
do
a good review. Thank you.
Just it says 3 decimal places, so we should write 1.960.
Oh, you're right.
Okay.
And then for the lower bound, we're putting in what we got on the test, right?
Yeah, so it should be that
Did you guys get
998.04.
998.040?
Yes.
998.04. Just a minute.
1.960.
0.0.
1001.60.
And the other one is 1001.96.
Okay.
960.
All right. To a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with and standard deviation of 0.01. N means to that a 95% confidence interval for the mean has a margin error of 0.0001. So I got 38,416.
So did I.
Which question was in the lesson?
This is question 6 from the lesson.
Oh, I
I got
have a question
C.
about
So it's 38416?
yes.
Okay.
Here's my question. The way I did it is I put the formula down and I just plugged in all A, B, C, and D for X and then found whichever one worked. But I don't know how to do the formula backwards if it shows up like it shows up here on question 9 with a blank. I don't know how to do it backwards with the square root.
What do you
So
mean?
you're supposed to square it. It's it's that formula.
It's 1.96 times 0.01 divided by the square root of X or the number.
Okay, so you need to go find the sample size formula, and that's given in that in the book in the lesson we just did.
Yeah.
It'll be in there because it says n equals.
It's under lesson 10 recap.
Is that under lesson 10? Okay,
Thank you.
Yeah.
under lesson 10, and it's the sample size
And it has-
formula. It's in there.
I'll write that one down too on my study paper. Okay. And number 10, Charity, you got to do one more.
Alright. Hold on, let me switch. Okay. The mean area of the several thousand apartments in a new development is advertised to 1250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis for a sample mean are. I did the last one.
Yes,
Yeah.
equal to m less than. So did I.
Yeah. Okay. Yeah. So D. Yeah, I do the same. Okay.
Yep.
So I'll go. Question 11. In a statistical.
Go, Malika.
Yeah, I'll go. In a statistical test hypothesis, we say we reject the null hypothesis with the level of significance if p-value is less than the symbol. I don't know.
Alpha. That's alpha.
Alpha,
That's
yeah.
what it's
So
called.
B,
I was like, I
I
cannot.
remember that one. That one I can't because it looks like an A at least. So it's A and it's alpha. I got that one.
so B, that's a vote.
Yep, that's
Yes,
what
I
it
think-
was. That's what I have.
So if the
Okay.
p-value is larger than alpha, so it's the A, right?
No, B.
No, B.
No, in the test we did, the question is like different. It's like the opposite.
Oh, wait,
Yeah.
it is? Oh,
Yeah.
Oh.
Look at the question. Practice, it says which one is statistically significant, which would mean the
Yeah.
p-value is larger. But in here, it's asking when we reject it. So it's the opposite.
Oh, good job. Good catch, Charity.
You say, hold on, I'm looking at that. In a test,
I had a question. What does it mean statistical significance?
So like when the p-value is going to actually make a difference. So when you don't reject it, that's when it's.
Oh, so that one in the book was larger. That was the answer because I didn't know. I wasn't sure with that one.
Yeah, so if it's statistically significant, then the p-value is larger than alpha.
Oh, okay, thank you.
Yeah.
Yeah, okay.
no, if it's statistically significant, I would say the value is less than alpha. Because it would be significant if we rejected the null.
No, it says in the book
I thought
says
it
that is rare. It doesn't say statistical. So I was confused with that one.
All right, but you guys have, what's your answer?
Here in this one it's easier. This one is B, but I was confused
Yeah.
with one in the book.
I put the answer for the book as well, and the way I read it is the same. So I'm confused by.
So statistically significant means that that we reject it or that we don't reject it.
I think statistically significant means we reject it.
Okay.
I think they're the same.
A group of statistics students want to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of 4 different apartment buildings. Data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer the question? It is enough that data for each apartment building are shaped with no outliers and the sample variances are nearly equal. Yeah, I think it's C.
I think so as well.
That one.
It's the same as the
That's
Okay.
what I had too. But I have a
question
question.
13.
Wait, stop right there. I have a question, even though I put C for the answer. It says no outliners and it's regularly whatever bell shape, but I thought it said something about that being right skewed.
Right skewed.
So I'm kind of confused.
Is the ANOVA supposed to be right skewed? Let me check. What lesson was that?
That was
That's the
just the last one, and its requirements are data in each group normally distributed. Create a QQ plot for each group. If no distinctive curvature, data is normally distributed. Variances are free. So I think that the F distribution, that only has to do with the F distribution, not the T or the Z, or it has anything to do with the data. It
Okay.
just has to do with the F distribution. That when you put it in, essentially in the applet, it's always to the right.
The F.
So it is supposed to be right skewed.
Is not, no, it's supposed to be bell. It's supposed to be normal. So this is correct. It is supposed to be normal.
Okay.
But they're saying the F distribution, rather than like with the T or the Z score where we could take one side or the other side, with this, in this case, with the F distribution, we should only be taking the stuff on the right and never, it's a value that's never negative, and you never divide it. The p-value you never divide.
Okay, thank you. A medical researcher is working on a new treatment for a certain type of cancer. Survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the sample for the new treatment and the standard treatment. In an early trial, she tried the new treatment and on 3 subjects that had an average survival time after diagnosis of 4.5 years. Small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population, the particular type of cancer. The researcher has committed a type 1 error. I think that was my answer.
That's what I got as well.
Yeah.
Okay, so A. Then question 14, if the level of significance, alpha, is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? It's by reducing the probability, no. The relationship is, no. Probability of committing, yeah. A?
Yes.
That's what I
A, by reducing type 1, we increase type 2.
Yes.
Yep.
Okay, good. That's what I got.
Okay, so question 15. The nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams, mu, I don't know, and no standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarette is 1.5, but measurements on a random sample of 100 cigarettes of this brand give the sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this test, the hypothesis. There's the hypothesis. At a 0.5 level of significance, you conclude that you should. Oh, this one. Which number was in the?
I think it's number 12.
This one I have a question on too.
So-
Once you do it.
Yeah, I'm confused. I was confused when I read this one.
What
Yeah,
did you-
I used a formula and I think I got D. Like I rejected.
Okay.
the-
I put B, but I think I did the formula wrong.
Okay, real quick. Let me walk you through then how I did it. We'll see if we can get somewhere.
Okay.
So first I calculated the Z-score.
Yep, that's what I
And I
put.
calculated the Z-score taken by the 1.53, which is the number that they got.
Yep.
Divided the mean that they provided, the 1.5, correct?
Minus.
So I subtracted that,
Yeah.
minus that, right? And then I divided that number by 0.17, which is the deviation that is known, right?
Yes.
Okay.
Mhm.
And so I got a number of 0.17647.
Wait, and you divided
Okay.
it by the square root of 100, which is 10, so.
Square root of 100.
Yeah.
Because it's the
So
same.
yeah, so you got 1.76.
So it should be 1.76. Because I
Yes,
didn't do the square root of 100. I skipped that step.
so it's 1.76 is greater
What
than,
is 1.7?
Okay.
is what I got.
I was
Okay,
confused because if I. So what answer did you get by working with this formula?
Okay, so after that, so now that we've got the 1.76, now we need to go get the p-value. So now you've got to take that 1.76 and go put it in the applet, is what I did.
But I didn't got that 0.76 that you were talking.
Oh, I just put it in the applet.
So
I got a different number.
what number did you get?
And then I got two answers, and so it just depends on the way I plug the numbers in the calculator. I got 0.6476,
Yeah, that's not correct.
Yeah.
and then I put it in the applet, and then I highlighted I think the right side, and that was the number.
92. What was it, not rounded? I put 1.76. Was it exactly 1.76?
1.76, you could go 1.764.
Or, okay.
So how did you get the 1.7? I want to get the same result, but
Yeah.
Okay,
We'll
so
help.
hang on.
Okay, so
And
I
then in the applet, this is what I was confused on. What side are you supposed to highlight? The
We
right?
should, since it's just the less than, right? Or is it greater than? Just the greater than. We want to know greater than.
Okay. That's
So
what I
greater
thought.
on the
than?
right-hand side.
so that means that the right side. Am I right?
Mhm.
Yes,
Yeah.
you got it, on the right side, which gives us a p-value of 0.0389, right?
Yeah.
And that is less than the level of significance of 0.05. So the p-value is greater, so we should fail to reject the null, correct?
No, it's lower.
So,
It's
okay, I'm still
0.03.
it's lower.
Oh, p-value is lower.
So we reject-
But I have a question. When we are in the formula, you have the 0.17 divided by the square root of 100. What is the answer you get from that?
Hey, Monica, so when here's the formula again, and I'll tell you the answer. It's 1.53 minus 1.5 divided by
Yeah.
0.17 over the square root of 100. And the answer
Yes.
should be 1.764 for the Z-score.
Mhm.
So when you put in 1.764,
But I don't know.
normal probability applet under Z-score,
And then highlight. Right.
highlighting the right side, you'll get the p-value for being 0.0389.
Okay, but that's the thing. I don't get the answer. Like I don't know why.
So let me show you
Obviously,
my
minus
screen.
86.7.
Let me share my screen. Hold on.
Okay, I'm just.
You might have an order of operations problem, Monica.
Okay, can you see my screen right now? And then click on my face if you don't see
No.
And then I'm going to go over here and I'm going to click on the normal probability applet. Do you see this?
Yes.
So
Yeah, but the problem is that I'm not getting the same number. Like I understand that part. I know how to work that part,
But you're
but
not
I'm not getting the 1.76.
okay, well, keep looking at my screen because I'm going to show you something else. So hold on just a second. Actually, I'm going to plug it into, I'm going to have you plug it into your calculator the same as me, okay? Do you have a regular calculator?
Yeah, I'm using my phone.
You're using your phone? Okay, I'm going to see exactly
That's probably your problem.
plug in. You have to use parentheses.
I don't have.
It's not going to work.
Yeah, if you don't use parentheses.
Oh, where do you put the parentheses?
Okay, so you're going to type in 1.53. I'm using my phone too to make it the same.
Mm-hmm.
1.53 minus
Okay.
1.5 equals 0.03.
Okay.
Then I want you to push the divided by.
Yep.
Then I want you to put a parenthesis.
Mm-hmm.
Then I want you to do 0.17 Then I
Yep.
want you to put a divided by. Then I want you to put
Yep.
another parenthesis, open parenthesis. And then I want you to write
Mhm.
100, well, do the square root of 100, but you can just write 10 at this point. So 10. Then I want you to do 2 closed parentheses. And
Oh, yeah. No, got it.
yeah, okay.
Yeah, so I'm, okay. Yeah, so I'll
right.
return. Thank you.
So then we reject
Okay.
it, right? Because it's less than.
Yes, and I didn't put that down yet, so let me update my quiz.
Yeah, if it's less, then we reject.
Okay, so we reject.
So 16, you would like to, thank you. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? Okay, let me read it. You would like to look at the mean number of hours. What this in the?
I think I put the
Let me see
paired one.
which. Okay, I put
Because
that
in
was
this case, we want the
13.
differences, right?
I wasn't sure if C or D is in that one, so no, I wasn't sure if it was C or D in there. If it
I
was
put the-
dependent or independent.
Isn't that determined by like the sample size? Like if you pick, like they want to compare male and female. So if you pick female, you're obviously also going to pick male,
I
think it's a paired sample.
right?
Okay, and I picked a paired sample test, and here is why. Here, I think, is the key. Is essentially, I think Charity's right because you got a male and a female. But if I were to try and calculate that data, they're asking for the difference.
Yeah.
Right?
Yeah.
So I would think we would take the male and the female and subtract them from one another to get that third column of differences, which you'll see in your, if you click on your quantitative inference. So I think that's why it's the paired sample key.
What is an independent samples test?
When they have no
It's-
relationship between others. I'm confused with this one because
yeah.
it doesn't say difference.
When they have zero relationship, then it's that you just have 2 separate samples, but they're not like related. Like we have male and female. The samples weren't related, then it would be independent.
I think it's independent because I don't think you would subtract the 2 because it's not a husband and wife, it's not a son or daughter, it's not, it's female.
Yeah, that's what.
You have
Yes,
to connect to each other.
Yeah, I'm thinking it was independent for the same reason. It doesn't
I
say
think it's
difference. It says you will like a random sample of 100 for each group and test if those means are different. It doesn't say difference. So I think it's
But if they're
independent,
different,
but I'm not sure.
I'm going to leave it on independent, and then someone else, whoever submits
Okay.
it will know after they submit it if it's whatever you guys want or not.
So this is question number 17. Is that where you are? Or 16? I don't even know
Number
anymore.
16. I
That
think
one is
16 independent. Not
So number 16. I'm going to go ahead and put in paired sample, and I'll submit first.
all right. Let me flag that one so that I don't. They put.
Should I continue?
Yeah.
Although I feel like you've done a lot already.
Okay,
I think,
and I-
and Monica or Melody, I think it's your turn.
Oh, sorry. It is my
We were
turn.
thinking about 5, so.
I'm looking at my questions on my paper. I'm like, we're not at 15 yet. 17. An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. This is paired. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling? We know it's dependent sampling, and it's going to be if you select a brother so as to compare his academic achievement to his sister, you must include the sister in your study.
yeah.
So that's going to be D as in dog.
Yes.
And then we'll go to the
So
next
D.
one. D as in dog. Yep.
D.
Use the following information. A soil scientist collected random soil samples from a field and measured the organic carbon level. look up the chart. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation? And I would say it's not telling us what the sigma is, so it's not known. So it should be confidence interval for mu when sigma is unknown, which is the first one, A.
Yes.
Yes.
Number 19. Which of the following is the 95% confidence interval for this analysis? Input your answer for the margin of error, lower bound, and upper bound. Determine the margin of error for the 95% confidence interval, and that's the 1.96, is that right?
Yeah, I think so.
1.960, do we want to put?
Oh, yeah.
Okay.
We might want to put the 0.
And then we're going to say input the lower bound, which should be 11.160. 11.160. And
Just give me a
then
minute.
Wait.
Hold on, what did you say? I can't there.
Just give me a
11.
minute. Which one? Were, so that was in the lesson was 16?
this is question 16, yes, of the lesson. And it would be,
Oh, in the I was like, whoa, we're on 20 something.
in the lesson, it's D as in dog, 11.168 and 15.217.
Okay, yes.
Is that what you got?
I
Yes,
got
yes.
something different.
Yes.
All right, let's hear it.
I got 11.520. So what is our mean here then?
All right, let's open the data file and redo it really quick. Mine's probably already still in there.
I mean, it's probably do that. So I'm trying to click through and see. I just didn't want us to move on until I caught up.
Let me see.
Do this really quick. This is going to be, it's not a paired test, it's a one sample test. Oh, I don't have any. That's good.
Okay, so there's that.
Yeah, it's one sample.
Organic stuff.
One sample test.
So then you have the variable 14.367,
And I paste the data
11.958.
in. So I got a mean of 13.193 when I put it in the one sample t-test.
Okay.
Yes.
And so you don't have anything in, 13.193. Yeah. And that gives you the confidence interval of 1.168.
No.
15.217.
No.
Do you have
You don't want greater than less than.
a confidence level of 0.95?
Yep, 0.95 for confidence level, yeah.
Oh, that's why. Haha. 0.95.
Okay,
Now I
we're
got
going back to
confidence interval of 0.9. Sorry, my bad. So it is 11.168 and 15.217. Okay.
so 21 is 15.1. Then the next one says a random sample of Hummers is for sale in LA and in New York. We want to know if there's a difference in the mean listing prices for them. Create a 95% confidence interval for the true difference of mean listing between the two cities. It says one of the 4 confidence intervals listed before, which is the appropriate for the situation. So I put that you're going to be, let's see, confidence interval for the difference of mean using independent samples, which is C as in cat.
Yes.
Yeah. I was confused with that one. I
Okay, yeah.
understood that it was independent, but I thought it was related because they were Hummers. But no.
No.
I just don't understand. But yeah, it's independent. I know that.
Okay, so
But I
the
don't
next one.
understand why.
The next one says calculate the 95% confidence interval for the true difference of mean listing prices. So when you plug it in, the lower bound should be negative 423. Is that what you guys got?
Yes.
And the
Yes,
upper
and then
bound,
541.
Yeah.
the upper bound is 5417.
poor ones.
And then the next one says, many studies have suggested there's a link between exercise and healthy bones. Exercise, oh, go ahead, what'd you say? Maybe I'm hearing things. Exercise stresses the bones and causes them to get stronger. So I'm skipping that part. Researchers would like to determine if the mean level of bone density are different between the 3 different groups of rats listed above. So we have 3 groups of rats. Alpha is 0.05, and so we're going to want the ANOVA test because it's talking about 3 different groups of rats, I think. Hold on a second. No, we don't.
Yes.
No, we don't. This is going to be the dependent samples. No, hold on. Let me see what number I'm on. 25 is.
No.
So maybe it's just 19, right?
Is
On
it
our-
19?
I think it is. Because that's
Okay,
what
yeah.
we need to do.
Test.
ANOVA.
Sorry, I'm getting all confused with these numbers and cross-reference. They calculate the test statistic. So this would be number 20, which is 7.978.
Yes.
Okay, I got a different test statistic.
Okay.
So for the ANOVA, because I have 7.978. Do you have all your sample means as 10?
We said 7.978.
Yeah, that's
Okay.
the answer.
That's what we have. Okay, 27.
Okay.
Gives you a p-value. It's 0.002.
Yes. Just give me a minute. I'm going to plug it. Yes.
Okay, moving on. Which of the following best express the conclusion of the test? Use the level of significance of alpha is 0.05. And we say that it's low, so we're going to reject the null. So there should be sufficient evidence to conclude that the bone density, let's see, that the mean bone density of at least one of the groups is different. So that's going to be D as in dog, from the mean bone density of at least one of the other groups.
It's rejecting the null. That means that there is
Sufficient.
insufficient or sufficient. There's sufficient.
There's
Sufficient,
sufficient
yeah.
evidence that the null
Okay.
is wrong.
I gotta remember that.
So D as dog.
D as in dog.
Okay.
There's sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of the groups. Yeah. All right. Then we go to next one. What's the correct hypothesis? So I don't know if we want to read this whole one. Perform the hypothesis test to determine if there's a difference for the mean cost of the non-stop flights when tickets are purchased 14 days in advance compared to the 90 days in advance. I know we're comparing 2 paired sets of data because it's the same flight we're comparing. Level of significance is 0.10. What's the correct hypothesis test? And it says it's going to be the dependent samples test.
Which one?
Dependent. It's A, B, C, D, E.
Yeah, E. Okay, yeah.
Okay, the next, I don't know. Yes, okay, the next one says calculate the test statistic, and I got 1.685.
Give me a minute. And
Okay, and we're good.
yeah, 1.685.
That's what I got, yeah.
I like when we can just pull numbers from the charts.
I know, it makes it so much easier than trying to figure out the formulas.
And then it says give the p-value. The p-value is 0.096.
Give me a minute. B 0.096. Yeah.
And then it was low. It's 0.096 is less than 0.10. So it's low. We reject the null. So we say that there is sufficient evidence to conclude that there is a difference in the cost of the mean cost of tissue gets purchased 14 days in advance compared to 90 days in advance. That looks like it's B as in boy.
Yeah.
Okay.
There's sufficient evidence that there is a difference.
So is B?
B as in boy. Yep.
And you know what? This one I half laughed at and questioned because I was like, wait a second, because if I round 0.096, it would be 0.1.
Okay,
but
I
it
do.
could be
That's
equal,
myself
so.
all the time.
And I was like, wait. But I figured, no, you can't round. You shouldn't round. So,
All right.
okay. All right. So we got it all. I'll go ahead and make sure I save all my results. And I'll go ahead and submit first and see how we did. Yes, submit the quiz. Processing. Okay. Scroll really fast down to the bottom. Okay, and we missed a couple up here. So let's go through one by one. Okay, so
Which one? We get 3 right? Which
that's
one?
what I'm scrolling through to find. Let's see. That one's right. That one's right. That one's right.
What did you got in question 3?
I think the question. We'll go back.
Okay, so the first question I got wrong is number 15.
Okay.
Number 15?
15. 15, yes.
And
I put
15.
15, 15, number
Okay.
15, because I had the answer reject. Oh, because I did the, oh gosh, that was my bad. So everyone else should have reject the HO. I accidentally put reject HA, so that was totally my bad.
Yeah.
I make sure everyone did reject HO, which was D, right?
That's right.
Okay, so that was totally my bad.
Can we check number 3, 4, 5, and 16? Just to know your answers.
Yeah, what's 3?
Back to number 3. Back to number 3. Sorry that my kids stole my mouse, so I'm trying to do this with the stupid pad. Number 3, I put yes, the distribution of mean, so it's C. I put 3. Question 3 is C.
Okay.
Yes.
Okay.
And what was the next one you wanted to know?
Then
5.
What was that again?
4 and 5?
4?
4? Yes.
4 was also C, the confidence interval for the difference of means using independent samples.
Okay. And 5?
And 5 is D, obtain the balances of 90 bank customers rather than 30. Very good.
You're right.
Okay, thank you. And then 16.
All right, let's go back down to. So 16, we did get wrong. I got it wrong, and I put a paired sample t-test.
Yeah.
So is
I
it
think you guys wanted it to be
Okay, so
D, the independent, right?
Yep. Independent samples t-test.
Okay, yeah, independent.
Okay, and then keep scrolling through here. Okay, I got question 19 wrong,
Oh,
which I have an answer of 0.196.
Oh, you missed the 0.
1.96. It's 1.96. 0.
Well, that's normally when they do this, they take the 0 off anyway. So I did. I put a 1.960, and I got it wrong. So
Wait,
real quick, this was, which data was this?
Yeah, but it's asking the margin of error, so probably we needed to work with a formula or something like that.
I'm trying to see 1.11. There it is. Okay.
Yeah, because it's not asking what is the 95% confidence interval. It's asking the margin of error.
that one we did wrong. So essentially we should have taken the lower bound confidence interval, right? Subtracted by the upper bound confidence interval and divided it by 2 to get the margin of error. Or there is a formula out there, but this is the easiest way to do it. So the answer, I believe, 0.025.
All right, but I want to do it.
Yeah, go ahead. No, you guys do it. Make sure you get the same answer as I did.
This is, let me find out what number this is on our paper.
The number 19.
Is it the lower minus the upper, or the upper minus the lower?
Hang on. So I want to say you take the lower subtracted by the upper. Lower.
Comparable to 16, or 16, right? So it's 11 point.
What's that?
It's comparable to 16 on the other two. For the-
So it's minus 2.025.
So 13.193.
Okay, it's not 13.193
I
What?
got 2.025.
because 13.193
Oh,
is
because
the
it's
mean, right? And then you should be able to take that mean, that 13.193, and add the 2.025 that we get, and should get our confidence intervals.
Yes.
Right? Is how that works, right?
Yeah, right.
I'm not sure. I added the two
And
intervals and I divided it by 2. Isn't that how we find out the 95%?
So you subtract the 2 intervals. Subtract them, don't add them.
yeah, you subtract.
You should subtract it and then divide by 2.
But I have a. But those are never negative, am I right?
Yes.
Correct.
So is 2.025?
Yes.
2.025. Then if I take 2.025 and I add it to the 13.193, I get 15,218. Well, and that's the tricky thing.
Okay, I'll submit with 2.025. Do we have another one?
Well, because I'm wondering, just because of the rounding, if we should put 2.024. And essentially, if I take the mean, the 13.193, and I subtract the 2.025 that I round to, I get, oh, I do get the right number. Okay. So do you put 2.025? So 2.025 should be the answer for number 19.
Okay.
What was that? What was that
Okay.
thing where it said you don't round? What was that? Remember?
It says you shouldn't round to the very, very end. And the
No,
only
no.
reason I'm,
There's a rule.
No,
There's a
there's
rule where
something
you
that
don't
said
round.
you're not supposed to round, whatever number it was. I know sample size you always round up, right?
yeah, the sample size, you always round to the nearest whole number, up to the nearest whole
I
number.
can't remember which one you don't round for.
I'll have to look it up for the test.
Yeah.
All right, so 2.025.
2.025. So someone put that in to
Do we
make sure it's right. And the only reason I'm questioning it is because the confidence interval, it's slightly off by one number. Because essentially, if I take that 2.025 and I add it to the mean, 2.025 plus the 2.0 plus the mean, which is 13.193, I get the 15,218. And the upper bound that we put in that is correct is 15,217.
Yeah.
But it's correct if I do that. So I think they do want that you to input the number directly from the Excel spreadsheet on the next two, which we did get right. And I think they do want us to round to that third decimal place for this one, so the 2.025. But you'll have to double check whoever submits next.
All
you'll
right,
have to
I
double
can
check.
submit it.
Okay. So we have
Okay, moving on. Any other questions, Monica?
now if we have to change another one before I submit.
Are there any other ones we got wrong?
Okay, I did. I got number 23 wrong. But again, that might be you. Hang on, let me. So number 23, I had a negative 423,238. Yeah, I put the number in wrong. Idiot.
It's negative 23, right?
It's negative 423.238 because it says round to 3 decimal places.
Oh, even though, because I was just circling my answers, I didn't redo it. So it should be negative 423 point what?
0.43, or it should be 238. So negative 423.238.
Okay.
And the next one should be, it is correct at 5417.336.
Oh, thank you.
All right, so negative 423.238 and then 5417.336.
Correct.
Okay. They're tricking us. I just copied and pasted into the Word document all my questions and answers, and now these aren't even matching our answers.
111, scrolling down through the rest. The rest we have correct.
All right.
Okay, so I'll submit. Yeah, I'll do it. Oh yeah, 1, 1. I'm checking 1. Yep, all of them are correct.
All right, let me just make sure I didn't
Hooray!
do something wrong. So, Charity, you go ahead and submit yours too, and let's just make sure we can cross-reference with Monica.
Yeah, because I had an issue just by putting the wrong number in, by fat figuring something. That's a problem.
Hey, Kayleen, do you need us to read back all the correct answers? Or
No, I made notes here. Yeah, it's just going to be a headache because I'm going to have to write them all back down again and resubmit it, but that's all right. It is what it is.
I got them all, so thanks, guys. This is good. All right, Charity, how's your Did you get them all right then?
Charity's looking. She's a very
Looks like I
pondering
got
face.
one
She's
of them
pondering.
wrong. Oh shoot, I just clicked on something. Oh, I went to the next page. Can I go back and look at my quiz?
I don't know if you can.
I don't think I can.
I don't think you can. I think you have to take it over again. But I think you can go see what your grade was.
Yeah, I can. It said I got one question wrong, and then I clicked on the next page on accident. All right.
All right. Well, I'll just, if you guys want to go, I'll just read through to her all the correct answers before I close mine, and she can type them in, and or you can stay on, whatever, either way. All right, Charity, let me know when you're ready, and I'll just start reading the
Okay.
write it down, and then I want you to confirm every one I say so that you have it exactly the same.
Have you stopped the recording?
We'll stop it if you'd like. Do you want me to stop the recording?
Yeah, we probably could at this point.
Yeah. All right. I'm stopping the recording.